Dear participants, a warm welcome to this a warm welcome to this auspicious and enlightening 5-day online faculty development program held during 15/9/2025 to 19/9/2025, arranged by the Department of Civil Engineering, RVR&JC College of Engineering, Guntur. I am happy to inform you that 1,063 participants have registered for this faculty development program, out of which 8, 9, 20 are faculty and 144 are from various departments. On this auspicious occasion, I request a well-disciplined, polite, cherished, and learned personality, our beloved principal of our college, to declare the start of FTP program and say a few words about our institution. I request our principal sir to give his valuable address. Thank you, sir.
Sairam.
Sir.
To Chief Guest, Bhushan Mohan
Rai Singhani garu, sir.
Bhushan Mohan Rai Singhani garu, Assistant General Manager, Structural Tata Consulting Engineers. Directors Dr. K. Ravindra garu, Dr. N.V. Srinivas Rao garu, HOD Dr. A.S. Prasad garu, other dignitaries and dear participants. Good morning and a warm welcome to the 5-day online faculty development program on smart materials and technologies for durable structures. Let me say a few words about the college. Rayapati Venkata Rangarao and Jagalambudi Chandramouli College of Engineering is the dream of an inspired group of eminent intellectuals and resourceful business leaders of Andhra Pradesh to impart quality technical education to young men and women. Established in the year 1985 under the sponsorship of Nagaj Education Society, which was established in the year 1963. RVR JCC runs with ACTE New Delhi, approved under Nagarjuna Education, Nagarjuna University, Acharya Nagarjuna University, Guntur affiliation. Today, it enjoys flagship status among the 8 constant institutions that are governed by Nagarjuna Education Society. During the 40 years of its quality sustenance, the institution has grown into one of the largest and leading engineering colleges in South India, with excellent infrastructural facilities and competent human resources. Today, it offers 11 BTech degree courses, 6 MTech degree courses, in addition to MBA, MCA, and BBA courses, with a total students of strength 6,200. The institution has been accredited 9 times for all eligible courses by the National Board of Accreditation in 1998, 2002, 2007, 2012, 2017, 2021, and 22, 24, 25. Had also received NAC A+ grade in 2021. On this auspicious occasion, I request the participants to participate actively in the FDP, gain the knowledge. Finally, greetings to all the engineers and future engineers. I wish you all happy Engineers Day. Thank you. Thank you, Ananda.
Thank you, Principal Sir. Now I request a man of certain but simple rules who is humble, realistic, inspiration for this faculty development program, our HOD Sir of Civil Engineering Department, Dr. A. Srinivasa Prasad Garu, to speak a few words for the participants. Sir, over to you, sir.
Thank you, Dr. Saira. Respected Bhushan Mohan Singhani, sir, Chief Guest of today's inaugural function, and Dr. Kolla Srinivas, our dynamic principal, and Dr. Kuminin Ravindra, sir, Director Academics, and Dr. N.V. Srinivas, sir, Director Finance and Administration, other HODs, NYTs, and media participants. A very good morning to all of you, and a welcome to this 5-day FDP on smart materials and technologies for durable structures. So first of all, at the outset, I congratulate all the participants for registering to this 5-day FDP program, and I am delighted with the overwhelming response to this FDP course. So about the department has been started since the inception of the college in the year 1985, offering the BTech Civil Engineering program. Later, PG program in structural engineering has been started in the year 2004. The department has been accredited by NBA, and the department consists of well qualified and experienced staff, and of course it consists of well established lab also. Department carries out research projects and offers consultancy also. With these few words, I, of course, once again thank all the participants, and I hope definitely you will be benefited by attending this FDP program by enriching your knowledge on smart materials and technologies for durable structures. So thank you one and all the best.
Thank you, sir. Now I request our chief guest, Mr. Bhushan Mohan Rai Singhani Garu, who is a professional structural engineer with continuous learning throughout his career of 14 years and now currently working as Assistant General Manager in Tata Consulting Engineers, to deliver his lecture on this auspicious occasion. Bhushan sir, please give your speech, sir. Thank you, sir.
Yeah, very good morning. I hope I am audible and visible to all.
Yes, sir.
Yeah. So good morning and happy Engineers Day to all the students and faculty members and the experts that are conducting this 5-day online faculty development program on very important subject of smart materials and technologies for durable structures. And the topics covered are very relevant for the industry, that are sustainable green materials, ultra high performance concrete, structural health monitoring technologies, artificial intelligence applications, repair and rehabilitation subjects. So we are constantly growing every day in these areas, and the academics and the research has to also progress accordingly. And I congratulate Department of Civil Engineering, RVR and JC College of Engineering, Gantur. Uh, Special thanks to the coordinator, Professor Venkata Sairam, Head of Department, Professor A.S. Prasad, and to the Director and Principal of the college for arranging this faculty development program. And also there are around about more than 1,000 participants that are actively going to learn through the process. And my focus, as I say, also the industry focus has been on the sustainable and resilient infrastructure and how these structures can perform more throughout the life cycle. So that is the durability requirement. Like a building is standing for 100 years in design stage. However, in practical conditions, it may last only for 50 years or 70 years. So this is one of a challenge that we are also facing in the industry. So this is very relevant subject, and I would like to give a quote for today, as it is an Engineers Day, by Bobby Knight, that the key is not the will to win. Everybody has that will. However, it is the will to prepare to win which differentiates all. So this is the moral boost that I get when I see this quote, and there is always a, uh amount to learn every day as an engineer. I would like to give focus to this term resilience, as I have been dealing it since last 10 years. So, in general, resilience refers to the ability to bounce back. In emotional terms, as a person, when something disturbance happens in your life, how you come back. Similarly, for the infrastructure also, how from the original condition after the disturbance of earthquake or any other disaster or any other incident, how we come back to the original state, that justifies the resilience. And resilience has four parameters. First is the robustness, that is how we design and how we prepare for it. Second is redundancy. Redundancy relates to how the additional measures are there that benefit the system before the event. That is the absorptive part. And there is rapidity, how quickly we can recover from the imbalance, and resourcefulness, which will limit the impact propagation. So these four R's are very important when we discuss on the resilience. Maybe in this FDP, you may go into deeper depths of it. Now, how mechanics and structural dynamics is important in this, I would like to say something on that. So mechanics, we in structures, we understand when we apply the loads, there is a response in terms of displacement, stress and strain, and we justify the safety and stability of the buildings or the structures accordingly. However, structural dynamics deals with understanding of the behavior, which is very important because mostly the structure behaves dynamically. We are converting some things into static. However, the real behavior is mostly dynamic, and how it varies with respect to time, like earthquake, wind, other vibrations, and the measures are mode shape, natural frequencies, and damping. So this helps in structural health monitoring as well, which is based on the vibration based methods. So in health monitoring, there are various methods that you may come across. One is the vibration based methods, in which the mechanics and structural dynamics is very important subject. And there is a difference in dynamics. One is the discrete model, that is you are lumping 100% mass of a beam at a center. That is a discrete model. Another is a continuous mass model, in which the mass is divided along the length of the beam. This is an example how the discrete and continuous mass model is important, because in health monitoring, it will capture higher modes of the vibration. If we go by the continuous mass model, it will have various behavior. It enhances the analysis power, and to get to the root cause of the issues that are in the structure. So this way, the structural dynamics is relevant in mostly all the analysis and design that we do in the industry. And continuously, there is a change in approaches, and artificial intelligence is also gets added to it, and that way we understand the behavior of the structure throughout the life cycle of its intended use. Now, another term is sustainability. So, I would like to read upon the agenda of sustainability by UN's Council. That is, in 2015, 17 Sustainable Development Goals were to achieve the peace and prosperity of people and the planet by ending poverty and hunger, protecting natural resources, ensuring health and education, fostering sustainable economic growth, and building resilient communities and infrastructure. These interconnected goals are supported by 169 targets and aim to balance the economic, social, and environmental dimensions for a better future. As civil and structural engineers, our target would be number one, quality education. Second would be industry, innovation, and infrastructure. Third is sustainable cities and communities. Fourth is climate action. So we are dealing with change in the climate. That way, the life of the structure is also affected. Also, we are using new materials like green concrete, ultra high performance concrete. Then in structural steel, we are going towards the composite construction, and there are many health monitoring techniques that we are using to continuously monitor the critical infrastructure in the country. And the only thing I would like to say is, when we are using with ultra high performance concrete for buildings, we need to be very sure that it is able to resist the fire, and be stable in those conditions as the size of the elements get reduced. And we are using 50% replacement of the cement with cementitious materials. That are the alternate materials we are using in the industry, using GGBS, silica fume, alcofine as the mix may require. And I think this FDP program has those important subjects covered. So I congratulate all uh, the organizing team who has planned this FDP program and invited me uh, for delivering this speech. Uh, so I uh, so best of luck to all the participants and the experts in the session. Thank you.
Thank you, sir, for your valuable inputs. Now I request our resource persons who joined the inaugural session to speak a few words. Now I request Dr.L.R.Manjunatha, sir, to say a few words regarding FTP. Manjunath, sir. Hello. Hello.
Let me.
Manju-
Okay.
Sir.
Thank you for the opportunity given to me to address today smart materials and technologies for durable structures. The theme is right and opt for today's new generation ultra modern construction technologies. The reason behind is that the world is going through a sea change. We have to address the climate change and also develop smart materials for construction. As the previous speaker, Bhushan Raisinghani sir mentioned from Tata Engineering that we need to use alternative materials like GGBS, microfine GGBS, microsilica, then ultrafine fly ash, and new materials because the grades of concrete is no longer M20, M25, M30 grade concrete. Today, city like Mumbai with high-rise buildings coming up or mega infrastructure projects, we are going with smart materials which are going up to 150 Newton per mm square, MPa strength. The next 20 years, no doubt that we'll be using M300 grades of concrete, ultra high performance concrete. As Bhushan sir has told that it has to be flexible, it has to be ductile, because fire resistance is very important. When you have design a high grade of concrete M150 or M300 grades, that will be more brittle because you're using a lot of cementitious material up to 1000 kg per cubic meter. It has to be ductile. So you need to have a certain kind of secondary reinforcement along with steel. And smart materials, nanotechnology is gaining acceptance. Graphene is one material people are exploring, and people are exploring geopolymer concretes, and new range of admixtures are coming, which are reducing the water cement ratio even up to 0.25 to 0.28. With these things, we need to really work on smart materials, smart technologies, because one more challenging is the availability of workforce in the Indian subcontinent. We don't get trained workers, especially we have two kind of workers in the industry or country, agricultural laborers. Those who don't do agriculture, they come to construction. So trained workforce is not there. We may have trained engineers, but trained workforce is not there. That is a big challenge. Go to any other country, whether a plumber, a barber, and an electrician, need to have a certificate, a mason, to practice his work. In India, it's nothing like that. The school dropouts who don't have much education, they could not get any other opportunity, they come to construction. That could not happen because it's now construction industry is no longer a labor intensive work. It is a smart work now. We are going for high rise buildings using high strength and high performance concretes. Need to handle all these new technology, new materials. We need to have trained workforce. That is one more challenge we are going to face. And I'm happy that there are more than 1000 plus participants registered for this FDP. I never thought that this is going to be a source success. Registration itself is that they're willing to join the program and listen to the speakers, smart material technology, because colleges do a lot of R&D work. So my suggestion to all the faculty members, don't do any R&D work or any project for the sake of getting a degree awarded to a student. Each and every project they take up, it should be something giving light to the society, which is going to help change the way the construction practice is happening, and they should start their own startup to develop these new materials. That's how, because India is lagging very much behind many developed economies in terms of research and development. Startups we may have, but that is not the case. Pure research work is not there, pure innovation is not there. So that has to be calculated in the minds of the youngsters who come for civil engineering field to do their research work or study civil engineering. and they should be trained properly. So I wish the program a grand success. This kind of participation I had never seen anywhere. 1,000+ participants, faculty members of 850 plus. Congratulations to the college which is organizing this. I would like to deliver my lecture after this presentation. Thank you. Wish you all the best for the entire program. Thank you.
Thank you for your valuable speech, sir. Now I request Dr. Srinivas Vagu, sir, to deliver his valuable insights on the inaugural session. Manjunath, sir, please wait for closing the inaugural session, sir. After that, we will start the session 1 by you, sir.
Yeah, thank you very much. And very good morning to all the esteemed faculty members and fellow professionals and the chief guest of the today's function, as well as the principal of RVR and JC College of Engineering. So it's my privilege to be here as part of this faculty development program on this smart materials and technologies for durable infrastructures. Actually, the theme is not only the timely, but also essential, as we are moving towards the new era of structural engineering, where durability is not just about the strength, but also about how we are going to adopt the intelligence, adaptability, and foresight into the future of how the structures are going to perform. So in that sense, actually one of the most transformative elements that enabling this shift in the technologies is the structural health monitoring, where I am working for past 2 to 3 decades on different aspects of the structural engineering, structural health monitoring, and analysis design aspects, and the different sensing technologies, analytical tools, everything. So I'll be talking about this SHM in the latter part of this session, maybe during my session. But I just want to tell about how SHM is important for structural engineering and how it is going to link with this today's program as well. So the SHM, mainly the structural monitoring, that is lies as the intersection of structural engineering, material science, digital technology, everything. By embedding the smart sensors kind of things, or the responsive materials or self-sensing sensors into the structures, whether embeddable or whether it is surface mounted, we are not only no longer limited to periodic or the visual inspection as we generally do, but instead we gain real-time insights into the structures, how they are going to perform, and how the degradation is going to happen in the structure, what are the different degradation patterns, and what are the hidden vulnerabilities of the structure also. So why this is going to be important? Because the durability today must account for, as the chief guest has told, the different kinds of dynamic loading conditions, catching infrastructure, extreme weather events, and also increased urban demands. As we are going to see day by day, there is a increasing demands of the structural loading conditions, as well as the structural materials and the performance limits as well. So SHM allows us to move from reactive maintenance to the predictive or the preventive strategies, and extending the life cycle of our structures and significantly reducing the long-term costs. So when combining the smart materials such as the shape memory alloys, or nowadays we are using the piezoelectric composites or the fiber optic sensing kind of things, distributed fiber optic sensing can be used. So we can transform the passive infrastructure into the active and intelligent systems capable of self-diagnosing itself, as well as in some cases even self-healing kind of things also, when we are introducing and you have a smart and mimicking kind of materials into the structure by appropriately adapting the structural thermodynamic system itself. So with this, I will just end my lecture, as this is no longer the future, but it is a new standard for creating a truly durable and resilient infrastructures. So I congratulate the program coordinators, principal of the college. So by organizing these programs like this FTP, which are very much essential in equipping the educators, faculties, and the researchers with the right tools that can lead to this transformation. So thank you very much, and thank you, one and all.
Thank you for your valuable speech, sir. Now I request Sri Subbareddy Garu, our resource person, to say a few words on this auspicious day. Thank you, sir. Subbareddy, sir. Hello. Okay. Now I request Professor S.P. Anchuri, sir, to say valuable words on this FTP program. Anchuri, sir, are you there, sir?
Yeah.
Yes, sir.
Good morning. Thank you, RVR and JCCE. Wish you first a happy Engineers Day. Now, I am pleased to join this inaugural session of SMTDS 25, wherein, as we know, the smart materials which are transforming the way we design the durable and sustainable and resilient structures. This particular program is a great opportunity to explore the cutting edge innovations that will shape you future as educator and even engineer. So stay alert, curious, engage yourself, make every session little interactive, because it's not just like a classroom sessions. So let us build a smarter and stronger tomorrow. In fact, I will be talking on the last day, because being a structural engineer and architect, the architect comes first, but I will be coming on the last day on the 19th, because I want to connect all the dots, like smart materials, built environment, more than that, the mindset of the smart people, because there is a need of transdisciplinary integrated design approach. So all the best and see you soon. Thank you.
Thank you, sir. Now I request Parshit, sir, to kindly give his valuable speech. Parshit, sir. Hello. Hello, sir. Are you there? Sir? No. Right. Dear participants, please wait for a few minutes. We will start session 1 after the vote of thanks. Kindly present me the vote of thanks. It is my privilege and honor to propose vote of thanks on this auspicious occasion with all the respect and gratitude to the chief guest, Dr. Bhushan Mohan Roy Singhani Garu, and other resource persons for spending their valuable time to enrich the inaugural session. I thank our magnanimous management members who always encourage such technical programs. I thank our beloved principal, Dr. Kolla Srinivas Garu, respected directors, Dr. N.V. Srinivas Rao Garu, and Dr. K. Ravindra Garu for their extended support in conducting this FTP. I thank our HOD sir, Dr. A. Srinivas Prasad Garu, and other staff members and department coordinators and co-coordinators for their contribution to this FTP. Dear participants, thank you for your patience and extended cooperation. Now, I request Dr. L.R.Manjunatha, sir.
Yeah.
Sir.
Thank you, sir.
Sir, now.
Yeah.
Now
Can I share the presentation?
Yes, sir. Please share, sir. Our faculty, Dr. M.L.N. Krishnasai, sir, will present the biodata of you, sir. After that, you can start the sessions, sir.
Sure.
Sure, sir. I made you presenter, sir. You can share the PPT, sir.
I'll do that.
Yes, sir. Now I request our faculty, Dr. M.L.N. Krishnasai Garu, to present the biodata of our session 1 expert session speaker, Dr. L.R.Manjunatha, sir. Thank you.
Thank you, Dr. Sairam. It is my privilege to introduce our first speaker of this FDP, Dr. L.R.Manjunatha. Dr. L.R.Manjunatha is an accomplished civil engineer, concrete technologist, research scientist, and sustainability leader with 3 decades of industry experience. He is currently Vice President and Head of Business Development and Specifications at JSW Cements Limited. based at Mumbai, specializing in business development and sustainability initiatives for green products with specifications. With a robust educational background, including a PhD in management on sustainability of green building materials and constructions, MBA, BE Civil, PGDM in lean management, PGP in concrete technology from City and Guilds Institute, London, UK, Executive PG from ISB, Hyderabad. Dr. Manjunatha has contributed significantly to professional bodies like the Indian Concrete Institute, Association of Consulting Civil Engineers, India, ISTD, GCCA, and has grown from managing committee member to chairman of Indian Concrete Institute, Bangalore Center in 2020-2023. And he has worked for various committees of Bureau of Indian Standards, focusing on sustainability, climate action, green building materials, and more. He has attended and presented his research papers on sustainability at multiple international conferences like Structural Engineers, World Congress, World Cement Association Conference at Singapore, Istanbul, and Dubai. He has published 73 research papers, has a readership of 95,000 on ResearchGate by 105 countries and universities with 115 citations with research score of 534 and has delivered over 800 technical lectures. Actively engaged in organizing and participating in numerous conferences and workshops, he is a member of several national and international committees. Dr. Manjunatha has received notable awards, including the CIDC Viswakarma Award at Technologist of the Year 2022 and Eminent Civil Engineer of the Year 2022 by the Association of Consulting Civil Engineer, Bangalore. Concrete Technologist of the Year 2023 Award from Concrete Engineers Association, New Delhi. Sustainability Leader of the Year 2023 from UBS Forum, Mumbai, and JC Puraskar Award by Garden City University in 2025. He is passionate about contributing to the sustainable development with his dedicated actions on sustainability initiatives in concrete constructions and climate actions. Thank you, sir. Thank you.
Thank you very much, sir, for the introduction. Respected Anjuris sir and eminent is my friend for long years. He's there, architect and practicing engineers. You are able to see my screen?
Yes, sir.
Yes, sir.
We
But
can
you
able
have to
to see
make it
the
full
screen,
screen.
The slides are moving?
Yes, sir. Slides are moving, sir.
Yes, sir. Audible, sir. Audible. Everything is clear, sir.
Sir,
Okay,
the
okay.
better full screen mode, sir.
No. Generally, if I put that, it is not moving. Is it moving now? Slides are moving? No.
They
Sir,
have to close and restart again, sir. That's possible.
No. I think most of the time I have seen it is a challenge.
Okay.
That's why I will always present in this mode.
Sir, it is clear, sir. Continue, sir.
I'll make it more, I think,
Zooms.
visible. That is better.
Yes, sir.
Okay. Okay. Thank you.
Yes, sir.
Thank you, respected sirs and delegates. I'm happy to share today my presentation on smart materials and technologies for durable construction. I've been working in the construction field for the last 30 years. When I started as a young site engineer, the concrete was M15, 1, 2, 4. It was not even 1, 1.5, 3. That was the concrete being used as a main concrete grade. So most probably it was all site mix concrete. In 90 to 93, I'm talking about, there was no ready-mix concrete available in the country. So somewhere the ready-mix concrete revolution started somewhere in 1995, 96, in that period. So many companies came from abroad. Till I remember the company called Fletcher Challenge from New Zealand and RMC India RMC Ready Mix UK, apart from Indian ACC starting the early penetration of ready mix concrete industry. Today, all over India, there are more than 125 cities having ready mix plants. Earlier, it was started in Mumbai, then spread to Bangalore, Hyderabad, and metros. Today, each and every district level ready mix plants are there. That is the way forward, because more and more site mix concrete should get converted to ready mix concrete. Globally, the penetration of ready mix concrete is huge. Almost 70 to 75% of the cement produced in those countries straight away go to RMC batching plant. That is not so in India. Even today, we are lagging behind. In spite of ready mix plants, our individual house builders, retail segment, still we use almost 50% of the cement in bag form, using cement bags, cutting the bags and putting into the mixers and making the concrete. So as we progress in next 20 years, I believe the way the construction industry is developing, the government push for infrastructure development like bullet train, smart cities, elevated corridors, expressways, freight corridors, new airports, new seaports. So much development is happening. With that, we need to go for innovative materials, innovative technology. There is a need. Whatever we are teaching in the colleges of old textbooks, when they come to the field, students, nowhere they can apply that. So we need to innovate. The colleges and the universities develop new curriculum. Apart from technical presentations from the industry experts, they need to bring in a focused approach in changing the syllabus, because not only you don't think that artificial intelligence, software like computer science, mechanical engineering, robotics, electronics engineer, semiconductor, there only the world is moving forward change. But the world in civil engineering is also moving very fast. Today we have new technology, new systems. So we can make concrete to sleep, concrete to get up. We can make concrete to set at what temperature or what time it has to be set. We can make the concrete to listen to our, like how you say, Alexa, you should play a song. Like that, we can make the concrete to behave. So those kind of smart technologies are coming. So we are nowhere lagging. Actually, we need to really work with global technology research centers who are spending a lot of time and investment on developing new generation materials and smart materials for the construction applications. So by today focus is on because even architecture also evolving, the kind of shapes the buildings are coming. Look at the skyline of Mumbai or Dubai or any other Hyderabad, in our own, or Bangalore. So no longer we can say we have to go and see the buildings in the foreign countries like Singapore or Kuala Lumpur or any other Dubai. We can see all those tall structures in Hyderabad only, or Mumbai only, or in Bangalore only. So we are also advancing very fast. So our students have to learn these new technologies to get their well-paying jobs, because always we believe that civil engineers are paid very less, they don't have job opportunities. That's why even after doing civil engineering, many people are migrating to software engineer or any other stream of engineering. That should stop immediately, because there's a good opportunity. India is building modern infrastructure. 50% of the cement production globally by 2050 will happen in two countries, China and India, because both the countries having similar population of 1.4 to 1.5 billion, need to provide housing, need to provide infrastructure, highways, roads, then mass rapid transportation systems. All these things are very much required. So smart materials technologies are very important, because we are not getting trained workforce. We may get trained engineers, but workforce is not available. You do hardly get very good construction workers in the field, and unless you develop smart technologies to construct, no longer will be able to build that renewed infrastructure development for the country. So background, today I'm talking about sustainable and green construction. What are the current trends? What are the architectural trends? A lot of architects friends are there, because they are going towards net zero buildings, green buildings, and a lot of innovation is happening in BIM 3D printing technologies. So India has built the largest 3D printed buildings by Lawson and Chubro for the Border Road Organization Training Center. They have built the largest 3D printed building in India. So India is not lagging behind any other country in terms of technology. Need to adopt and take it forward. So future trends in architecture and construction, and conclude with my concluding remarks. The new challenges for the world. Okay, the new challenges are huge population growth. India is witnessing a very huge population growth, and also good for the country. Almost more than 50% of the population is at the average age of 28. So that is good for the country. We get young workforce to work for the country, for the development of the country, in terms of technology, in terms of artificial intelligence, in terms of construction, in terms of mechanical, in terms of defense sector. So we have the huge population which is able to outsmart a trained workforce, the trained engineers, because India is producing one of the largest engineering students, engineers, young engineers in the world, close to 1.5 million engineers every year. So increased urbanization, more and more the people are migrating to the cities for better employment and also better medical facilities. We are creating more and more urban dense clusters like Bangalore, it's 1,000 square kilometer, Mumbai, 1,000 square kilometer, talking about Mumbai 3, Mumbai 4, and Mumbai is getting merged with Pune very soon. Now Bangalore is getting merged with surrounding areas like Tumkur, Mysore, and other areas. So the urban centers are growing much faster, like Hyderabad. Like if you go to Hyderabad, the high-tech city, it is nothing short of a Dubai skyline. So these things are continuously happening because more than 50% of the Indian population, from the current 30% to 50%, will be living in the urban centers. That means to say, as the population grows, what entire 1.4 billion population will migrate to cities. So that means to say we are creating more and more concrete jungles. So the jungles where earlier animals were there, now we are creating thousands of square kilometer concrete jungles where human beings are going to inhabit the space. So climate change means more and more buildings means more and more carbon dioxide emissions. And coming to that point, because construction industry alone emits 30% of the total global carbon dioxide emissions. So climate change is affecting us. We have got an extended rainfall. We are getting concentrated rainfall, almost 1 month rainfall or 1 year rainfall happening in few hours. So we have seen the Uttarakhand and other places, the sliding of mountains because of the cloud burst. In many places, not only in India, the whole world is seeing that climate change, the floods happening and washing away the human habitat, the crops, whatever. It's changing very fast. So need for sustainable infrastructure and housing. So we need to build because no longer we can support a population with the current existing infrastructure. We need to build and rebuild. Okay, old structures have to be demolished where the floor area, FSA is increasing. Mumbai completely coming under redevelopment. They are even demolishing 20-story buildings. Can you imagine? 20-story buildings they are demolishing and going for 100-story buildings because the residents are going to get additional income. They are going to get more carpet area. If they are living in 1 BHK, they are going to get 2 BHK because they increased the FSA. So things are happening. Entire Mumbai is going to be redeveloped. Similar way, those things are going to come in cities like Bangalore, cities like Hyderabad or Chennai or Delhi. Redevelopment is the continuous mantra because we need to house and accommodate more and more human beings in the same congested space. Sustainable architecture. Architects are now going towards net zero buildings. So they are designing. They are going for IGBC and Griha certification. No longer mandate. If they are going one step ahead, net zero building. That means to say they are not going. So whatever the carbon emissions are coming, that is equivalent to that. They are saving the carbon dioxide in terms of construction. Okay. So technological innovation in architecture and construction, raw material storage, and need for new sustainable materials, sustainable cement and building materials manufacturing. So these are the new trends which are happening in the construction industry, and we are part of that development. As I told you, my dear Friends, the background for construction is the cement. We are going to use cement, and concrete is the second most consumed material on this planet after water. So we continuously consume concrete because this is a most economical material, abundantly available. In terms of other product like steel or aluminium or timber, this is more sustainable. But we need to look into the way we are going to use the cement. We are going to use the cement for construction and developing skyscrapers. Because every ton of cement produced is emitting carbon dioxide, because we have the limestone, which is a material which is used for making cement. Limestone is called calcium carbonate. So this calcium carbonate is getting converted into calcium oxide. As I told you, my dear friends, as the world move towards huge urban population growth, the world 60% and above by 2050 will be living in the urban environment. The population growth by 2050 will be 9.2 billion people from the current about 6.8 billion or 6.9 billion population. So population is continuously increasing. That too in the developing countries like India, China, then Bangladesh, or we have the Malaysia, Indonesia. These are the huge population growth centers. So we need to develop relevant infrastructure development. So this is one photograph, the clogged cities where the concrete jungle. You see, even in forest, if you go, there are more, the trees will be having more, little bit space. Here you can see the concrete jungle. More and more high-rise buildings are going to come. This entire small buildings will be demolished and will lead to high-rise buildings. So this is a concrete jungle where we have high-rise buildings, concentrated living, people living in like cages. Okay, so this is going to be the future, because we need the urban slum development, redevelopments are happening of the slum. A city like Mumbai, the redevelopment is going to happen. This entire stretch next 5 years will not be there. You can see only tall buildings like this after 5 to 10 years. Then, once again, as we migrate to the cities, all the cities roads are getting clogged. This is the traffic. Go to any cities. Don't say Bangalore only is having more traffic. Of course, it is there. But go to any cities, traffic is a major concern. People move towards their work, or when they want to move towards their recreation centers or shopping centers. So all the highways and roads getting clogged. Weekends, you can see all the highways full of people, vehicle, because owning a car is not a big thing nowadays. Like most of the middle class people are owning their cars. So they come out with their own vehicles and getting clogging the road infrastructure. So these are the adverse effects. So the adverse effect of urbanization is the rapid development of cities, lack of sanitation, poverty, unemployment. Cities not only attract educated people, they also attract the workforce to provide the facility to the middle class people or highly skilled people. So you get maids, you get carpenters, carpenters. They cannot have their own this thing. Taxi drivers, all kind of people migrate to urban centers in search of employment and livelihood and better facilities. So this is leading to global warming and leading to urban heat island effects. So urbanization, pros and cons. So people may get better public transport, but high level pollution, okay, noise pollution, light pollution, higher chances of homelessness, because people start living in slums they cannot afford. City like Mumbai, you want to have a small 1 BHK, you have to spend not less than 30 to 40,000 rupees per month. If you are not earning so much, your earning is only 25,000, you tend to live shared apartments or maybe slums. So that's how the cities are getting shaped. So concrete jungles are there, then we need to really work to support the population. So the future depends on how we can develop smart materials, smart energy, and how we can have smart construction. So smart construction comes with challenges. So sustainably we have to construct, because every year the world construction industry and other related industries are emitting 50 billion tons of carbon dioxide. So 2/3 of the emission, 30% of the emissions of these 30 billion tons come from construction industry alone. So we have buildings, we have iron, steel, cement, other industries using materials which emit a lot of carbon dioxide. So cement industry, I want to dwell more on cement industry, how the emissions are coming from the cement industry, because we are using limestone to make cement along with clay or iron oxide. So here we are making that mixture of these fine materials and heating up to 1500 degrees centigrade. We are heating it up to pre-heaters, pre-calcination, where we are removing carbon dioxide from the calcium carbonate, that is limestone, and taking that raw meal, heating up to 1500 degrees, setting in the rotary kiln by using firing through your thermal sources like coal or alternative fuels. So at the end of the day, we are emitting close to 925 kg of carbon dioxide to make 1 ton of clinker. Okay, so we need to really work on that, because as we consume more and more cement, India is already consuming 450 million tons of cement last year, and the installed capacity is close to 700 million tons. So we are going towards 1,000 million tons installed capacity and consumption of 700 million tons of cement by 2030, because we are building more and more infrastructure projects. So significantly, we need to work the impacts of impacts on construction because of sustainability challenges we face is the dust of 10%. Then we have the greenhouse gas emissions of 30%, energy consumption up to 40%. And we know we have to live with the concrete because it is the second most consumed material on this planet. So this is the challenges. So we encounter huge challenges, increased carbon dioxide emissions because of higher consumption as we go forward. Then landfill space and additional cement plants are going to come. The usage of water also is tremendous, increase in land use. So these are the challenges we face continuously when we go towards sustainability goals. So as we know, and challenges are more, we cannot stop the construction. High-rise buildings are going to come. This is the skyline of many developed geographies. The Burj Khalifa, World Trade Center. Then we have the Shanghai Center, Kingdom Tower, like that. Similar way in cities like Bangalore, Hyderabad, or Mumbai, we are already seeing towers up to 50 floors, and Mumbai towers up to 100 floors. We are seeing that is the skyline of Mumbai, and is going to increase further because Indian geography requires more and more tall structures. So sustainability needs concrete is the low energy footprint material still compared to any other material like aluminum, stainless steel, glass. So concrete comes at 1.4, okay, energy in terms of, but this issue remaining is that how we can make it more and more sustainable. Okay. So we require a lot of resources. World cement production in 2019 was this much, and going forward, the cement production is going to go up substantially, as I told you. Okay, so we need to produce low carbon concretes. So low carbon concretes require sustainable, smart materials. Okay, so ready mix is one thing which is shaping the Indian economy, Indian construction atmosphere by producing high quality, high strength, highly durable ready mix concrete, which is not possible with site mix concrete. So when you use ready mix concrete, we can use alternative material like GGBS, fly ash, or calcined clay, or lime powder. So we can use construction and demolition waste. We can use high performance admixtures, and why not? We can use even carbon food technologies also. So ready mix concrete is the way forward where we can use various technologies to achieve required strength and durability parameters. So JSW, I am from JSW, and as a company, we produce a lot of slag from the steel mills. We produce a lot of fly ash from thermal power generations. Both are supporting industry. We have adopted a circularity in our manufacturing process by adopting and using sustainable green material like fly ash and GGBS and other slags in the manufacturing process of cement and other CC products. So where we stand today? Where we stand today is that we need to continuously evolve ourselves to augment the sustainability agenda, to reduce the carbon footprint in the construction. So this is possible only by adopting new materials, new design, and new methods. Okay, and also adopting sustainable urban solutions. So there's an urgent need for sustainable development all around, as I told you, my dear friends, that is there. So already I've discussed about the parameters of reducing the carbon footprint per 1 ton emissions. And going forward, we need to reduce the greenhouse gases because already the global temperature from the prehistoric levels has gone up by 1.5 degree as on last year. So if we continuously touch the temperature of 1.5 degrees centigrade next 5 years, so already we have reached it. If the temperature goes up to 2 degrees centigrade, more than the prehistoric levels globally, then further we are going to have more and more catastrophic effects. We are going to have hurricanes, we're going to have many typhoons, we're going to have many adverse environmental effects like cloud burst and floods. These are all going to affect the environment. And urban heat island effect is one more parameter which is affecting the global environment. So cities are getting more and more polluted. This is what we can see. The maximum pollutions happening in India and African countries and China. So other places are relatively okay compared to these countries because more and more consumption of cement and development is happening in these countries only, where they consume cement and they don't have much of a ready mix plants operations, and still the concrete manufacturing process as site mix concrete. So already I talked about urban heat effect, and like the cities are getting more and more warmer compared to the surrounding neighbor area. So we have a temperature gradient of 2 to 3 degrees centigrade. I studied Bangalore temperatures going up to 1.5 degrees centigrade compared to last 20 years. The growth because of the concrete jungles, we're creating more and more jungle. There's no passage of air flow through the centers. So as I told you already, the percentage of emissions coming from cement industry, steel industry, and thermal power generations. So we continue to use thermal power generation even 2070, where we're talking about net zero emissions from India. Still, we'll be using thermal power because to support the 1.4 billion now, or that may be 1.8 billion population by 2070, or 1.9 billion, we need to have alternative sources. In spite of developing more and more green energy footprint, still will be depending on thermal power generations. We need steel, we need cements to build the infrastructure. Okay, so emitting parameters, we have India standing third highest in the world after China and America. So need of the hour for all the civil engineers is to go for sustainable development. How the Romans had developed concrete technology 2000 years ago. They have built Roman Colosseum, Roman Pantheon structures, still they are durable, long lasting even after 2000 years. That means they did not use cement at all at that time. They used volcanic ash and other binders. They used lime and other binders. So we know these materials are not available. Volcanic ash or lime available in plenty, but cement is available in plenty. So our sustainable the goal should be achieving the economic benefit, protecting environment, and social benefit for the society. So these three cycles, triple bottom line, is very important for developing sustainable solutions. That can happen only through going for green building construction. Green building construction is nothing but adopting green building materials, sustainable solution, green practices in developing the green ecosystem based on the architectural benefit. The 10 best way to do best construction, a smart construction, going for precast concrete technology, going for advanced shear wall technology, going for 3D printing, using not masonry, using AAC blocks in terms of bricks, okay, using BIM, big data, and other innovative practices. So this is the way we can have the best construction practices to develop sustainable buildings and green solutions. Okay, so this requires huge resources. As I told you, you require more cement, you require more steel, you require more AAC blocks, or you require sheets, whatever is there. We need to use and bring technology to reduce the carbon footprint in not only in construction but also in building material sourcing. So the value chain or the logistics chain, supply chain is very important. So as we go forward, there will be materials now in the smart materials, smart building materials, where they come out. I'm using 1 ton of cement. So you'll be asking what is the carbon footprint called EPD value, in environmental product declaration. So that is gaining acceptance now. The countries like Europe or America, they ask any product they want to use in the construction, what is the EPD value? The lower EPD values products are preferred over higher EPD value product, that's called global warming potential. Okay, so this is what actually the future of construction by 2071. So you'll be using artificial intelligence, cloud collaboration. So there will be less and less workforce, and we'll be using more and more machine drone technologies we'll be using, okay, for inspection. So that will take care of this thing, cloud collaboration, sensors, remote structural health monitoring, and robotics. So the previous speaker was telling structural health monitoring is very important, because when we are using so much material in the concrete construction and designing the buildings for 100 years, 150 years, so continuous monitoring of the structural health, like mega structures like bridges, tunnels, or high-rise buildings, whatever said and done, we need to monitor the strength and performance of the concrete regularly. So the future of architecture and engineering, sustainable cities, green landscapes, urban gardens, green materials, artificial intelligence, and future-ready cities. Okay, so cities will be like automatic, how we use our smartphones and all. So they'll be intelligently interacting. Okay, so now already we have system traffic management, AI-based traffic solutions like Bangalore is adopting, where based on the movement of the traffic and all, traffic congestion, they'll be diverting the vehicles. So that is technology is going to come, and more and more innovations are going to come, and our students and our faculty members also have to adopt these things, because they need to train the young engineers properly, so that they will remain in civil engineering only without going to other fields of engineering for employment. So need for technological upgradation is very important. As we build the structures, the concrete jungle, now it is a glass jungle. The glass jungle gets changed to the eco-friendly way of green buildings, where even we can grow plants on the buildings, small trees. So this is one example I'm showing, that these things are coming now very often, that you are going to create urban forest, and you can create an urban garden where you can grow fruits, hydroponic farming, or you can grow vegetables. Okay, so we cannot depend, because the farmers all leave their farming and they may become workers and come to cities. That's how, because in America only 3% of the people are involved in agriculture. In India, still we have got 40 to 50% people involved in agriculture. The trend is going to change. So we need to create urban jungles only. So going vertical is the future. We need keep on in vertical building, because of the transportation systems. We are having metros and other thing. More and more people start living near to their work place, and they need a place near to the work place. So that means to say they are going vertical. So we will be moving from conventional to performance-based design and specifications. So how performance based? Okay, now we are talking about M20, M25, M30 grade concrete, 124, 1.5, 3, 112. That is going to be the future. That is not going to be the future. That is going to go back. We are going to design a grade of concrete. Okay, based on the carbon footprint. Okay, I am designing M20, M25, M30. What is the replacement of cement by GGBS or fly ash? 30%, 40%, 50%. We are going to design what is the carbon footprint. That means to say, I am designing this 50% GGBS. Okay, this is the emission norms is only from 230 kg per 1 cubic meter. So I am using fly ash 30%. My emissions are 250 kg. So I prefer a concrete which is having lesser carbon footprint based on the design specifications. So the performance-based design goes for placing control, durability, and ductility and structural performance, because we are going for more and more high grades of concrete ductility is important, and structural performance of the concrete, because we're designing the structures for more than 120 to 150 years of service life. So we need engineered materials. The admixtures are changing every day, the way concrete is being made, because the admixture technology is one thing which is able to address the performance of the concrete in terms of reducing water cement ratio, high performance concretes, high flowability. You need to pump the concrete up to 1 kilometer. Let us say I'm going for high-rise buildings. I'm going to pump the concrete for a long distance. So admixtures are playing a very important role, and structural behavior is changing the way we are using admixtures. We can use the cement, we can use the SCMs like fly ash, GGBS, or metakaolin, microsilica, other products. So finally, admixtures, the modified admixtures, PC-based admixtures, they are very important. They have to give long-term workability, and along with that, high strength. These are the things. So supplementary cementitious materials are playing a very important role. They are available. We have limestone powder, fly ash, slag, natural pozzolana, clay, and other products from the various manufacturing process. The process industry byproducts are available, like red mud is available, like copper slag is available. Using these products, we need to work. The world is moving towards that kind of a development, creating, along with nanotechnology like graphene and nanotubes, nanomaterial we are using in developing high performance concrete. So new housing technology for construction is that, so we are going away from the brick and mortar technology. We are going for precast technology where you can reduce the size of the element. You can construct much faster. And so we are going for 3D printing. We are going for drywall technology where you can have a drywalls. We can just put the drywalls and construct it very fast. It's a composite structure. As previous speaker told, composite structures are becoming and gaining more acceptance. So shear wall technology, like my one format, which is making construction much faster, it has been adopted by many cities now, Bangalore, Chennai, Hyderabad, Mumbai, and all. They are only going with shear wall technology because it eliminates the huge demand for workforce, much faster, quicker. You can do it much faster, and also the quality can be assured. Some of the high-rise buildings, you can see these products have used sustainable green products like GGBS or slag cement or PPC-based cement. Pashmina Towers, Presidential Tower, Mantri Pinnacle, some of the high-rise buildings in South India. These are the live examples. I have taken the photographs. As I always interested to share the knowledge to my engineering community, my faculty members, because you may not be having opportunity to go and visit these places, but that's why I've taken. This is a precast technology, Purvankara. You can see by using precast technology, you can build these high-rise buildings. And the connections are very important. Now, the precast technology also, it's advanced now. The connections, the joints are done properly. There's no problem at all. Okay. Mass housing projects are gaining acceptance. People are developing mass housing. BMTPC has developed perspective systems for mass housing projects in 5 ways. So, see, buildings can be made somewhere and joined together. Smart technology. Okay. You can see the buildings are like fabricated somewhere, moved on a truck mounted trailer and installed at the site. This is quite common. Light gauge steel construction. This is a smart technology. These are technology to build faster. Okay. So your time is avoided. Like now the floods are devastating in Punjab and other cities. So you need to build structures quick. So BMTP is coming handy so that you can construct in 3-4 months and hand over to the people who are homeless, because these technologies will help to construct the housing much faster. 3D printing is one technology which is gaining acceptance and growing much faster now. So this 3D printed, you can print to any shape. So you can print faster. Maybe in 1 month you can have the entire building. The building can be printed in hardly 1 week time. So you can finish it by in 1 month, which otherwise takes almost 8 to 9 months. So you can use alternative materials. This is done with a mud, raw earth. Okay, so printing can be used, need not be cement. You can use various metals, various materials eco-friendly materials, smart materials. Using nanotechnology, you can design an ink. So you can have any color, any shape, any design material. So look beautiful. These are the technologies. So coming to the concrete materials, don't spend much time. Already I've discussed concrete is very important and workability is very important, because every day in and day out we use concrete and materials and be much faster here. So, sir, how much time I have still?
Sir,
Hello.
up to 12 o'clock, sir. 45 minutes
Ah,
is
okay,
there, sir.
then no problem. Thank you
sir.
so much. Thank you. So concrete durability is also very important. Durable constructions are very important. So we need to design structures. I would like to have a water, a glass of water. So concrete durability is very important, because we are building the structures. Most of the structures now, India is having more than 7,000 square length of 7,000 kilometer length of coastal line. If you take even Andaman Nicobar Lakshadweep Islands, it is more than 12,000 kilometers of coastline. So most of our structures and other infrastructure projects are coming along the coastline, because so coastline is gateway to the other world. We can move the goods and material. Lot of ports are coming. Lot of manufacturing facilities are coming to, like China. China model is that they have built their entire infrastructure manufacturing along the coastline, so that they can put all the materials onto the ship and transport to any part of the world. Because India is also becoming a manufacturing hub now, Make in India initiatives and other things. So, and the China plus one policy of the world economies now, they want to invest more money on India, because the coastline, entire coastline is going to be completely developed. Coastline plus 100 kilometers, that range, so that you can easily move the material to the ports. There are more and more new ports are being developed, because you require concrete which is highly durable for the coastal environment. Should be able to resist sulfate attack, chloride attack, alkali silica reactions, carbonation effect, and seawater alternative wet and dry conditions. So in order to do that, the concrete has to be highly durable. So durable concrete comes through a very good design approach. We need to use supplementary cementitious materials in spite of cement. We need to use high quality aggregates, need to use recycled water for making sustainable construction to improve the durability of the structures. So sustainable concrete, how we can call any concrete sustainable is by optimizing the material usage. So let us say I am using 400 kg cement. Instead of 400, can I make the concrete with 350 kg with, to get similar M40 grade concrete strength? Okay. What is the kind of smart materials I have to use? What is the innovation I have to use? So innovation is nothing but, smart material is nothing but, we know cement, we know GGBS, or we know fly ash. There are other materials we have to activate them, like alkali activation for geopolymer concrete, okay, nanotechnology, graphene material, or using recycled aggregates. So we need to use the available material, which is in limited source, to actually participate in the concrete manufacturing process to get durable and high performance concretes. So new generation green materials the construction comes through using mineral admixtures, chemical admixtures, alternative to river sand materials, alternative to coarse aggregate, nanomaterials, geopolymer, and conventional and non-conventional material like bamboo, which is also gaining acceptance now. Bamboo materials, aluminium, plastic, and polymers. Okay, so Indian code also IS 456 permits the usage of high performance uh, mineral admixture like fly ash or GGBS in the concrete making. Fly ash you can start it from 15 to 30% we can use. GGBS we can go up to 70%, because GGBS is both having cementitious properties as well as pozzolanic properties. So these are the mineral admixtures. Already I had shown you the chemical admixtures. Mineral admixtures are microsilica, fly ash, metakaolin, and GGBS. These are very good products. As I told you, we need to have a product which can replace 25 to 70% just like OPC cement and easily available and also reduce the carbon footprint. So this is one product GGBS. Any disturbance? Okay. So we need to increase the durability. Today the topic is the dual
Sir, please
smart
wait.
material for durable construction.
Dear participants,
We need to reduce the life cycle cost. These are all the very important things. So how the GGBS comes? GGBS come from steel plants, having a blast furnace as a process of making steel. So we get high quality steel. Then also 30% of the uh, byproducts is slag. So when we eat limestone, iron ore, along with plexus like bauxite, up to 1500 degrees centigrade, we get molten slag along with molten iron. So molten iron we take for various steel manufacturing process. Molten slag is for making GGBS or the slag cement. The replacement levels and based on the application, we start from 25% up to 70%. So based on early requirement of strength, we can go up to 35% like precast elements or post-tensioning concrete applications, and we can go up to 70% for marine structures, sewage treatment plants, and corrosion-resistant structures. So the advantage of using slag is that already it has suffered emissions during steel manufacturing. Only we have the grinding emissions. That is only about 60 kg per every ton of GGBS, where cement, Portland OPC cement comes with 850 kg emissions. So by replacing that, we can really bring down the emissions in the concrete, either in the manufacturing cement or in the manufacturing concrete at the RMC batching plant. And advantages of using the GGBS is that it is a double reaction. Okay, when we add water to the OPC cement, it gives three components. One is the calcium silicate hydrate gel, then calcium hydroxide or Portlandate and yttringate. Okay, calcium aluminosulfate. So this combination is calcium silicate hydrate gel is 50%, calcium hydroxide is 20 to 25%, calcium aluminosulfate, yttringate, it is about 25%, balance 25% voids are there in the concrete matrix. That is after the concrete is set. So what GGBS will do or slag will do, it reacts with calcium hydroxide and convert into CSS gel again. So the interfacial transition zone, that is nothing but space between the cement paste and aggregates. It is always weak. So by adding this fine material, which is finer than cement, GGBS, we are creating and filling the voids, and also secondary reaction takes place and bonding the particles together. So the bond strength will increase. The bond strength between the aggregates and the cement paste will increase, and the bond strength between the reinforcement and the concrete matrix will improve. This way, we can improve the performance of the concrete. So the strength properties, better long-term strength, 56 days, 90 days strengths are almost more. It's go up to almost double the strength in 180 days. Durability is important, lesser cracking. So these are the added benefits of using slag in the concrete. And also the reduction in the carbon footprint. I've done a small calculation with 40% replacement of GGBS with cement, and every I just calculated for South India. So South India produced an average of 30 million cubic meter of concrete annually. That was the estimation done. So it's if you're using 40% GGB slag in the concrete, equivalent to 4 million trees. 4 million metric ton of carbon dioxide is saved. I'm just giving an example of one product, how this is affecting. 4 million trees, imagine, can you imagine 4 million trees in a forest? How dense the forest will be? What is the area of the forest? It's massive. There may be Bandipur or Nagaravale or some other forest area. So I've done a calculation. So let us say somebody is doing 10,000 cubic meter. If you are using 40% slag GGBS, you can save 1,050 trees. 25,000 cubic meter we can save 2626 number of trees, equivalent to planting number of trees. If you're doing 2 lakh cubic meter of concrete for a big project, it's equivalent to 21,000 trees. So this is the calculations I have done for each and every, the practically I have done. So the multiple benefits of using slag or GGB as a smart material is that the factor of safety, the design life gets enhanced, then the serviceability, the service life of the structure will increase, reduce the carbon footprint. It's a architectural wonder. So we can get brighter finished concrete. If you're doing white topping concrete or anything finishing also, we can have an exposed concrete where you don't have to do the painting also because of its whitish in nature, and continuously it is gaining strength and durability. So blended cements are there. We know slag cement, we know PPC, we know composite cement. Now LCC cement has been already started manufacturing in India in a big way. So these are the blended cements. India is producing close to 73% of the total cement production is blended cement. So using blended cements is very important. If you are doing any site mix concrete, don't go with an OPC 4353 grade cement. Go with a blended cement of PPC or slag cement or composite cement. It's very good and highly durable concretes, because this is the various codes I'm just sharing with you for various types of cements: Portland slag cement, composite cement, LC3 cement. Many cements are there available in the market. You can make use of those cements. So blended cements in India clearly evolving, and more and more adaptation of these blended cement should happen in concrete making. So in terms of performance, long-term strength, I've given example OPC, PSC, then composite cement and PPC. I'm given 4 parameters: long-term strength, alkali aggregate reaction, chloride, induced corrosion, carbonation induced corrosion. In all the parameters, the blended cement, PSC, CC, PPC, they are performing much better than OPC cement. So that's the reason we should use it. And it gives the our alignment with circular economy. So using blended cement, blended concretes with SEMs will give a circular economy, and very good for our country like India, where we are expanding our footprint in terms of housing, infrastructure development, roads. India government now they're planning 50,000 kilometer of highways and expressways. They are designing more than 100 airports, new airports, 100 seaports, and they're expanding continuously the urban infrastructures like metros. So all this requires a huge quantity of cement, a huge quantity of secondary cementitious material, blended cements, steel, because we need to construct them more economically, more sustainably. So this is one more. This composite cement is very good in terms of durability. JSW is manufacturing this composite cement like JSW Comcem, which is available in the market. You can make use of these products. In terms of performance, it's very good compared to OPC cement, even PPC cement. This is ticking in all the parameters like eye strength, eye finish, eye final strength, quick setting, chemical resistance, increased durability, superior cohesion, greener product, heat of hydration is less, lesser cracking, and reduced bleeding. Similarly, this is one more slag cement, which is also very good in terms of performance compared to OPC cement and other cements. Slag cement is available from JSW. So I'm giving an example of environmental impact from the manufacturing of the 1 ton of product. Already I've told you, cement, GGBS or fly ash, you take. So as compared to the cement, the climate change parameters is less, energy usage is less, mineral extraction is less, zero, waste disposal is zero, and also eco point score. Eco point score is much lower compared to OPC cement. Environmental impact for 1 ton of concrete, when making concrete using blended materials like GGBS or fly ash, that is also very good compared to 100% OPC mixers. 50% GGBS mixers comes with 85.4 kg with respect to 142 kgs of OPC mixers. If you're using 30% fly ash, 118 kg greenhouse gas emissions. Primary energy usage also get reduced. Mineral extraction also get reduced, because using these smart materials and smart technologies, it is always impacting the environment and also reducing the carbon footprint. This is an example of embodied CO2 reduction, slag-based concrete. Okay, so 70% GGBS mix is liberating only 139 kg CO2. Then fly ash, 50% if I am using 203 kg. Compared to the OPC emissions of 370 kg for every cubic meter of M30 grade concrete. So you can clearly see how the emissions have been reduced. Coming to the next point, use of blended cement, GGBS in concrete matrix, environmental benefits. So here going to a circular economy. Okay, GGBS manufactured from waste product or byproduct of steel industry really helping to use this industrial byproduct or industrial waste, some people will always call, to get the circular economy. Okay, resource conservation. We are preserving the natural resources like limestone. If I are using the cement in the current stage, the limestone reserves will get exhausted in 30 to 40 years. So, like that way, we need to preserve the limestone for the next future generation, fresh stones, because you cannot continuously break mountains and degrade the natural environment. Okay, you need to really go for using sustainable aggregates like recycled aggregates. Reduction in the greenhouse gas emissions is very important, and also saving of energy. To manufacture any new product, you require a lot of energy. So we require a lot of green energy. The same energy can be consumed for lighting the house, lighting a building, instead of going to burn a limestone or an iron ore to get cement or steel. So usage of GGBS in concrete matrix, I have told you like how we can reduce. We have got Bangalore, Mumbai or Hyderabad. So examples of concrete cost. So we can gradually reduce the cost of concrete also. So generally people look at, okay, it should be economical. Okay. So for more common grades, we are using a blend of 50% GGBS. In the most of the matrix, it is always economical. This also we have done a comparative results. So in terms of the reducing, one company, JSW, has done really very well. JSW Cement. The global average of cement production is 608 kg for every ton of cement manufacturing. Whereas in India, it is around 560 kg average, Indian average. So JSW stands at 242 kg. Because of that, we have been nominated as the world's least carbon footprint company. That is the advantage of our group company. Okay. So JSW, PSC, and GGBS certifications, the EPT certifications are available these products. We have the CII Green Products and Service Council given certification. So we have the Environment Product Declaration for most of our products, where when you use these products, for every ton usage, you can just calculate this is the CO2 emissions from the iconic projects. So using the products, so many projects have been benefited. They have got many awards also. Going forward, I'm going to talk best examples of practical examples, because faculty members should also know like what I am talking is not from any textbook. Whatever I am talking is only because of the practical applications. My 30 years of experience in the field, where so many projects have been done with using smart materials. Brigade, Purvankara, Prestige, Shobha Developers. So some of the examples I'm just showing you. Some of the highway projects, Bangalore-Mysore Expressway, Bangalore-Chennai Expressway. Then this is Nice Road. This is a mass housing project for a housing project of Karnataka state government. So it's not only the builders or developers are using, it's all government agencies. This is a housing slum development corporation. When they are building structures for the lower income group also, these products come in handy, reducing the carbon footprint. So project like Bangalore Metro Corporation, Chennai Metro Corporations, they have been using continuously using this smart materials, the GGBS or the microsilica. Bangalore International Airport Terminal 2, which has got global recognitions and global awards for sustainability and sustainable development. So we, by using the green sustainable material like GGBS, they have saved close to 1.2 lakh tons of carbon dioxide, equivalent to planting 1.2 lakh trees. This is the taxiways and other infrastructure projects at Bangalore International Airport, where they've used almost 40% slag as an alternative material. Bangalore-Mysore Expressway, you've got Bangalore-Chennai Expressway. This is coming to 3D printing. Okay, so 3D printing using smart materials. This IIT Guwahati students, where JSW has given raw materials to them to develop. They printed tables. They are sitting on the table only. So after doing the graduation, they have started their own startup company for 3D printing technology. So why I'm telling this as an example is that students, whatever the project they do, just to get a degree and search for a job, they should become entrepreneurs, start their own startup. So we need to train and develop students' mindset. At least 30% of the students who are studying, they should become their own entrepreneurs. 4 to 5 people. Now government is supporting. They're giving funds. Karnataka government up to 50 lakhs rupees for a good startup. They are giving funds free. There is no interest. There is no nothing. There's a design competition. Elevate. In the similar way, many other states also they have launched funding the startups. So the startup is good. Apart from that, you get venture capital. There are so many foundations who are supporting the startups. So don't let us not create engineers only to get employment. Let us create engineers to develop an entrepreneurship spirit, new products, new innovations. Coming to the JSW group, I would like to talk about my group. It's very big group of $24 billion. We are into building materials. We are into steel manufacturing, cement manufacturing, energy manufacturing, paints, and other things. We are growing fast. We have started our EV, JSW, MG Motors. We have the footprint. We are launching EV vehicles also. So we are spread across India. We are currently mainly operating in South India, Western India, and Eastern India. And very soon our plant is going to come in Nagaur, Rajasthan. With that, we are going to cover central part of India and northern part of India. And currently, we are 20.6 million metric ton capacity. Recently, through IPO, we entered the share market. We launched it successfully. It was subscribed 7.7 times. So these are the green products JSW cement is manufacturing. Not only cements, we are manufacturing ready-mix concrete. We are manufacturing ready plasters, eco-friendly waterproofing products, and floor hardeners, tile adhesives. So there is a range of products JSW is manufacturing and giving to the industry. All products are having IS certifications. So when you look at smart materials, green materials, we are there to support all of you. And this has been endorsed by many government agencies like CIDCO, MMRDA, Kempegowda International Airport, many big companies, Tata Consulting Engineers, Tata Projects, Saparji Pallonji, many top industries, ready-mix plants like Ultratech, Prism Johnson, Nuvoco, ACC, they have been continuously using these products. So many residential and commercial buildings are also using Shobha, Raheja, Hiranandani, JMC projects. Everybody is using these products. So moving towards net zero is not so easy. It is a continuous process, continuously evolving process. It's not only the embodied carbon. We have only 13% of embodied carbon and balance 26% is the operational carbon. So we need to use smart materials, not only in concrete, smart fixtures. We need to use 5-star rated energy efficient fixtures in the buildings, not only in the plumbing system, also in the lighting system. So moving towards net zero is efficient lighting, double insulation, where it maintains the temperature. During winter, it is getting heated. During summer, it's getting cooled. So this is called double insulation. So using technology, we can make that energy management is important. Maybe a building or maybe an apartment. Then Using rainwater harvesting is very important. Waste heat recovery is important. Also, using photovoltaic panels for using sunlight for energy generation called solar. It's very important. High performance windows and doors, very important. So windows act as a inlet for transmission of air and maintaining quality. So fixing up windows as per the sun movement direction for light and other things is very important. Air sealing of important, okay, dramatically reduce the largest source of heat loss. So heat loss and heat gain, we have to work on that. So these are the various systems we adopt for green building solutions. Okay. So cementing a new concrete future is very important using smart materials, smart technologies. Dealt for the last 2 hours. I've been continuously talking about green materials, green sustainability, precast technology, 3D printing. So these are all very important. Where the participation of the academia, colleges, industry, if the faculty members teach get involved themselves with the students just to finish this chapter as per the syllabus and my job is over. That is not the way. You need to create future engineers, because today Engineers Day celebration is there. So how we build smart technology, smart materials, smart innovations, and bring into regular practice is very important. So we live our dream, very important. So we need to train and put all our efforts, because after mother, the next are the gurus. Okay, Guru Brahma, Guru Vishnu, Guru Deva, Maheshwara. So like that, the gurus are important, and gurus should take a very active role in developing students. Nowadays students are always with mobile. They always arrogant. When I go to colleges, they always now teachers are complaining. Go to many colleges. This new generation students are not good, sir. They're not caring. They don't listen to the classes. Sir. We have a challenge. The Gen Z student, they call them. So we need to really train them properly so that we develop systems for our country. So whatever is available, we need to put efforts and put our heart and soul in developing new future generation engineers. So, in conclusion, I would like to talk about technological innovations are important in construction. Moving towards sustainable material usage is important. Usage of IoT, artificial intelligence, BIM important. Sustainable architecture is important. Mass housing, low cost, innovative, and sustainable materials, township developments. At the end, we are moved towards net zero emissions by 2050 in construction. That's very important. With this, I would like to conclude my presentation. I'm open for Q&A. Thank you, the college, for providing this wonderful opportunity to share my light. I'm very happy that a huge number of participation is there. More than 1,000 delegates, about 50% have registered here. So thank you very much for this wonderful opportunity on the Engineers Day. Would like to wish all of you happy Engineers Day. Thank you very much.
Thank you, sir. Now I request all the participants to kindly unmute your mic and proceed for any queries. Dear participants, any queries, please unmute your mic.
Hello. Hello. Am I audible?
Yeah, you're audible, sir.
Yeah, Dr.L.R.Manjunatha, it was really nice presentation.
Thank you, sir. Thank you so much.
Yeah, this is Dr. Saurabh Joshi speaking from Kolhapur, Maharashtra.
Yes, sir. Hi, sir. Hi, sir. Thank you, sir. You have joined from Kolhapur, Maharashtra. Very nice.
Yeah, I'm working as a head of the Department of Environmental Engineering.
Yes, very nice. Very nice to hear from you, sir. Thank you.
Yeah. My question is that the role of ESG, environmental social governance. Will you please something comment on it, sir?
See, ESG, okay. People treat it as separately ESG, environmental, governance, societal. See, they all together, okay. See, we need to protect our environment, okay, to achieve the societal goal. What is a societal goal? Is to give a clear water to all the people, to provide housing, provide infrastructure development, increase the economical benefit to the people. Okay, how we can achieve? We have to achieve through a sustainable way at the cost benefit. Okay, environment, we have to protect environment. The global temperature is going 1.5 degrees centigrade. So when we want to control the temperature, reduce the carbon emissions, we need to work with materials, work with technologies. Smart buildings are very important. Okay, so this is a triple bottom line where we achieve sustainability at the most cost economic way to benefit the society. That is the hallmark of ESG.
Yeah. Thank you very much. Also, my students, we were having UG environmental engineering, PG environmental, and PhD environmental engineering also. So one of my student is working in the field of life cycle assessment, and another
Okay.
student is working in the field of carbon footprint. That these are nothing but the cardinal need of the hour.
Yes, sir. You share your number to me. There's one on the building. Like yesterday, we have released one handbook. I want to share to all of you. This is handbook. We have calculated for every cubic meter of concrete using various materials how we can reduce the carbon footprint. Readily reference book is available. You can use that book. Actually, I've already shared on my LinkedIn. All of you can log Dr.L.R.M. LinkedIn, where this is Global Cement and Concrete Association.
Okay.
I would like to share with the organizing authority. You can share it to all of you, and also you can just ping me on my LinkedIn profile, Dr.L.R.Manjunatha. So that already I have uploaded that book up 143 pages. You can all use that book. If you have any doubts and all, you can always come back to me.
Yeah. One more student under me, he is working in the field of clean development mechanism, CDM.
Very nice, sir. Very happy to hear that. Would like to associate with you to help anything further from my side. My number is available. I think I'll just share my number.
Good morning, sir.
Title slide it is there. On title slide it is there. Your number and email ID.
First, correct.
First slide.
Yes, sir. That is my number. Yeah, very true. Yes, sir.
Good morning, sir. Manjunath, sir.
Hello. Just minute. And Manjunath, sir. Even
yes,
we are taking the help of mechanical department also, and we were working in the field of green building. So there is a one ANSYS software which gives me the idea and more detail about the heat flow in the building.
Okay. Very nice.
Yeah, heat flow in the building, heat gain, heat loss, so that we can go for Grih, LEED, ASHRAE, like this certification.
Good, sir. Doctor, sir, we will interact definitely. I'll also have make you associated with one one company is there. They are working on a lot of competitions. Okay. Solar Decathlon. Solar Decathlon. Okay. Every year they conduct a program and all, so you can also participate in that.
Sure, sir. I'll just ping on you WhatsApp. So, and I'll be very happy that in future we will definitely get connected.
Good, sir. Very nice, sir. Very nice for the interaction. Nice interaction.
So, good morning, sir.
Yes, sir.
Am I audible?
Yes, sir.
So, this is Dr. Priyamnath Bhomik, sir, from Madanapalli, Andhra Pradesh.
Madanapalli. Oh, okay. Andhra Pradesh. Very nice, sir. Madanapalli is my favorite. You are famous for mangoes.
Although I am not from Madanapalli, I am working here. I'm actually from Assam, and that is why when I saw the spelling of Guwahati, I just told you it's wrongly spelled. Anyway, sir, it was a nice session.
Okay, sometimes
it's fine. Sir, I had some queries. Actually, HOD sir was speaking, so I was just holding on the mic.
Dear participants, kindly.
Very difficult.
Some cross-talking is happening.
Sir, please avoid, dear participants, kindly avoid cross-talk. Dear participants.
Yeah, please, if you
Sir,
can,
sir. Sir.
am I audible clearly now?
Yes, sir. Prem, sir. Go ahead, sir. Go ahead, sir.
Yeah. So actually, it was a nice talk, and to be very honest, I have been working since the past 1 year with this alternative cementitious material. I have used pre-treated LICA, expanded clay, metakaolin, all these kind of things. But to my surprise, and I mean, I'm still struggling to find like optimization and all can be done with the help of the tools which we have now.
Yeah. Mainly using admixtures, we can do the optimization.
Yeah, and even the optimization thing we can take care with this ML models and all. There's it is very easy, but the concerning thing is about carbon dioxide emission calculation. Like it
No, that
happens.
I told you already. There is a reference book we have been releasing.
Yes, literally. I
So I'll
heard
share.
it, but
You can just go to my LinkedIn and click on that. Recently, I have shared. Yesterday only, I have shared that.
No, I
You
heard
can
that, sir.
download
I
that.
heard that. I will download that obviously, but just I want to know for a minute from you, sir. Actually, during my PhD also, I did my work on the reduction of carbon dioxide emission from bitumen using some nanocomposites, and I was successful in reducing around 70% of carbon dioxide. But the
Yes,
difficult
sir.
part is to measure quantify the carbon dioxide. So if I do not know what amount of carbon dioxide is emitting from that concrete mixture, how do I able to
So
reduce
it's
that
very
one? That
easy.
is,
I tell you. See, cement. Let us say you are using. Let us say 1 ton of cement, or let us say 1
yes,
cubic
sir.
meter. You are using 300, uh, 150 kg. Let us say. So for
Yes,
1
yes,
ton
sir.
of, I just give for simple to
Yes,
everybody's
sir. Yes, sir.
understanding.
Yes, sir. Yes, sir. Yes, sir.
So
Yes, sir.
you let us say you multiply that. Okay, for 1 ton it is 800 kg. 800. Okay. For 1 cubic meter using 150 kg cement. Let us say. So 0.15 into 0.8. That will give. Then GGBS you are using. It is 60 kg per every ton. You are using 150 kg. 0.15 into 0.06. Aggregates also you calculate. Water also calculate. Take various parameters you are
I
using,
understand.
you tabulate it, then the emissions will come to you.
But surprisingly, when we test it in real field, for example, we have offset gas analyzer for determination of carbon dioxide. So when you test it in the real field, like exact what amount of carbon dioxide is emitting, it is seen that whatever is given in the codes or any other papers, they are not matching, sir.
It will
They're
not
not
match,
actually
sir.
matching.
See, we had only calculation based on the emissions. Okay. So we
Okay.
are taking a theoretical calculation. So let us say
Yes, yes, sir.
one cement plant is emitting, let us say, to make 1 ton of OPC cement. The plant to
Mm-hmm.
plant, it will vary.
Yeah, that
Location to
varies.
location, it will vary. Product to product,
Yeah.
it will vary. So you are taking the assumption. So this is what, as per the statement available or the declaration given by the company. So you are
Yes.
calculating. So how do you find out the emissions from the concrete? You cannot find out. No, you are only calculating. I am using this material. This is the proportion. Okay. If I use pure OPC cement, this would have been the emissions. Okay. So I am not using the pure OPC. I am using an alternative material. So
Yes.
if I using a recycled aggregate, there's emissions. You are taking all the parameters that may be available. You put that into calculate, and that is the way. I don't know how you are measuring that emissions through any
Actually,
test method.
I did measure the emission from bitumen with that offset gas analyzer during my PhD days, and I also have 3 publications out of it. I mean, I have done it, but concrete I am failing to
No,
do so.
bitumen is
That is,
different. Concrete is different. Bitumen is different.
that's what
Concrete
I
is
wanted
different.
some suggestion. If there any case whether we can actually capture the carbon emission and do it, or we can just do it in the tabulated
No,
form,
no.
like you
See,
said.
cement they capture. See, cement manufacturing they capture. Concrete
Okay.
there is no capturing method. No,
Okay.
it's
Okay, sir.
only
Okay.
materials
That's
you are
what.
adding and how much you are
Yes, sir. I
finally
got
ending
you.
up with the product.
I got you, sir. I got you, sir. Sir, thank you so much for your time. Thank you so much for it.
Sir, good morning, sir.
Critically.
Manjunatha, sir.
Sir, good morning, sir.
Good morning,
Sir,
sir. Good
this is
morning.
Ramakrishna, sir, Dr. Ramakrishna from Gayatri Vidyabhasha, Visakhapatnam. Hello.
Sir, go ahead, sir. Your voice is audible, sir.
Sir, good morning. This is Ramakrishna, Dr. Ramakrishna from Gayatri Vidyabhasha, Visakhapatnam, sir.
Sir, namaste. Sir, namaste. Tell me, sir.
Manjunatha, sir.
Yes, sir. Ramakrishna sir, I'm not able to hear you.
Sir, I'm Ramakrishna, sir. Sir, you have been talking about blended cements, right? Sir, blended cements actually, the Portland slag cement or Pozzolana cement or LC3, these are not available in the market, even for research work also in Andhra Pradesh and foreign.
Sir, so where is you are from which place? Sir?
Visakhapatnam, sir. Visakhapatnam. Gayatri College.
Visakhapatnam is known for GGBS availability. There is a
available is there, but in
plant,
market we are not. Yes, sir.
Sir, just check. ACC is also making. Then Sagar Cement is also making. JSW Cement may not be available there, but other brands are there. Ultratech is making a PPC cement. Sagar Cement is making, and a couple of companies are there. ACC also having a plant there.
Yes, sir. But I mean, like for loose, they have not given. For mass only, they are giving. Mass competition only they are giving.
No, you have to buy a bag. So generally, don't go to company and all. You want to buy, tell students to buy one bag from a retail counter and start using it. That's all.
Sir, what about this LC3? Sir, LC3 cement is that available?
LC3 now they started by now JK Cement somewhere in Rajasthan. Because wherever the clay is available, even there also you have to eat the clay, calcined clay up to 800 degrees centigrade. That is now made available in the North India market. South clay is not so available. Nobody have started manufacturing. It's available only recently. Last month only they have launched LC3 cement.
Okay, thank you.
Clay is available in Rajasthan and Gujarat area. So there only it's available.
Thank you, sir. Thank you.
I think another only 5 minutes have. I should not want to disturb the other upcoming speaker. So let us close it. I suggest any questions are there that can be collected by the organizers and send it to me. I'll send a written answer to all of them. Maybe probably that is the better way.
Sure, sir. We will collect the questions raised by the participants and we will send to you, sir. I kindly request you to present the vote of thanks for the session, sir. Dear participants and respected Dr.L.R.Manjunatha, sir, on behalf of our organization committee, our faculty development program, I take this opportunity to extend my heartfelt gratitude to Dr. L.R.Manjunatha, sir, for delivering a highly insightful and thought-provoking session on sustainable green materials for durable construction. Sir, your expert lecture has enlightened us on the significance of sustainable practices in civil engineering and the role of innovative green materials in enhancing the in reducing the environmental impact and shaping the future construction. Once again, thank you, sir, for enriching the session and for motivating us towards a sustainable future in construction. Thank you very much, sir, for joining our FTP, sir.
Thank you so much. Thank you for the wonderful opportunity given to me. I think how many people participated today?
Sir, right now, 412 participants are there online, sir.
Oh, that's very nice, and hope
in
that my lecture has benefited.
I
will share my PPT also to everybody's benefit.
Yes, sir.
You can circulate to all of them. Okay.
Yes, sir. I will post in the WhatsApp group, sir.
Sure. That also you do, and add me in the WhatsApp group. I will be there, and also I'll share that calculation reference book also on the same group. Okay, sir.
Okay, sir. I will add you in the WhatsApp groups. Okay, sir.
Yeah. Thank you so much. Thank you. My pleasure, sir.
Thank you very much, sir. Thank you, sir. Dear participants, please find the feedback link in the chat box. I request you all to kindly fill the feedback link and please use your participant ID for filling the feedback form. We will use the ID for mapping the daily session attendance, and I once again inform you all that 80% attendance is mandatory as per our college policy for giving the participation certificate.
Sir, where can we find the ID, sir?
Sir, we already posted the list of participants in the WhatsApp group, sir.
In that we find it, sir. Okay.
Yes, sir. Once again, I will post the list of participants in the WhatsApp group, sir. Please find. Dear participants, we will be up to 12:15 for submitting the feedback form. Dear participants, list of participants with participants ID is again posted in the WhatsApp group. You may find the list of participants in the WhatsApp group. Any queries, please post in the chat box. We will forward to the resource person. Sagar sir, Sir said Sir will share the PPT, sir. After that, I will share in the WhatsApp group, sir. And Sir also shared some links, sir. That also I will share, sir. Sagar sir, is that okay, sir?
So the next session is at 2 p.m.
Yes, sir. Yes, ma'am. Yes, ma'am.
Okay.
Next
So we can.
section will be at 2 o'clock by Dr. Srinivas Voggu, Chief Scientist, SARC, Chennai.
Okay. So we can leave now after
Yes, ma'am.
something.
If you have submitted the feedback form, you may leave, ma'am.
Okay. Thank you so much.
Dear participants, if you have submitted the feedback form and if you don't have any queries, you may leave and please rejoin at 2 o'clock. We will inform when the link is active in the WhatsApp group.
Excuse me, sir.
Yes, sir. Yes, sir. Please, sir.
Sir, participants are writing their ID on WhatsApp.
No need, sir. No, actually, no need, sir. No need of writing in chat box, sir. Just fill the feedback form, sir. It's enough, sir.
Okay, thank you.
Thank you, sir. Thank you, sir. Dear participants, no need of submitting your participant ID in chat box. Please fill the feedback form. It's enough.
Hello, sir.
Yes, sir. Go ahead, sir.
Sir, is it to be sent in the WhatsApp group itself?
No, sir. Feedback form is posted in the chat box, sir. I am again posting, sir, in the chat box. Please find link, sir.
Okay.
I just posted the feedback link in the chat box, sir. Please find, sir.
Okay.
Sir, will we be getting the recordings of the sessions or?
Definitely, sir. After completing all the sessions, the recordings will be downloaded from the Cisco WebEx website. They said that after completing the FTP, they will provide a unique link where we can download all the sessions. After that, we will share the link also, sir.
Okay, thank you, sir.
Sure, sir. Thank you, sir. Dear participants, please find the feedback link in the chat box. After filling the feedback link, you may leave the session. And
sir,
I request you all to kindly join.
Share link, sir. Feedback link.
Sure, sir. Sure, sir.
Sir, chat box is not finding.
No, sir. We post. Sir.
You have posted, but a lot of messages are there. So.
Sir, again I posted now, sir. Please find, sir.
Mobile, it is not seen chat box. How to open?
1 minute, sir.
Mobile, it is not seeing the chat box.
No, mobile. I have done from mobile itself. It is open in mobile also, and again in computer also.
No. We are not getting that.
Just scroll it down, sir.
Chat box, sir. Chat box.
It is not there in my mobile. What happened? I don't.
Chat box.
Actually,
Participant ID.
Sir, if anyone wants participant ID, please post your name in the chat box or request me on voice. I will verify and give your participant ID. Dear participants, in mobile, you can find the chat box at the rightmost side of the corner. Dear participants, if you, please find this comment symbol, and in that comment symbol you can find the chat.
Hello, sir.
Okay, sir. Okay, sir. Nice.
Hello, sir.
Sir, please, sir. Go ahead, sir.
Sir, the participant ID was not found, sir.
Sir, please tell your name, sir. We will
Dr.
verify, sir.
Vagisha. Dr. Vagisha. VAGEESHA.
VAGEESHA. Sir, SMT 359, sir.
SMT 359.
359, sir. Yes, sir.
Okay, sir. Thank you, sir.
Sir. Thank you, sir.
Sir, my ID Manohar Pakade.
Manohar sir,
Pakade.
Sir. 1 minute. Sir, SMT 599, sir.
Okay, SMT.
SMT 599, sir.
Okay, thank you, sir.
It is common for all the sessions, sir.
Hello.
Dear yes, ma'am. Go ahead.
Hello, sir. Dr. P. Vasanti.
P. Vasant. One minute. Dr. P. Vasanti. SMT 398, ma'am.
Okay, sir. Thank you, sir.
Sir, Swati, MVSR Engineering College, sir. SS Swati.
Okay. Madam, are you from Matrus?
Yes, sir.
Subbarao. Right.
Yes, sir.
SMT 663, ma'am.
SMT 663.
Yes, ma'am.
Okay, sir. Thank you.
Dear participants, if you have filled the field,
Hello,
go ahead, sir. Sir, go ahead, sir.
Sir, Jayant Kumar, APWD, Kachal, Andaman Nicobar.
Sir, nice meeting you, sir. How are you, sir? Sir, Jain, sir.
Okay, sir. Sir.
Sir, 1053, sir. SMT 1053.
Okay, sir. Thank you, sir.
Right, sir. Right. Dear participants, if you have filled the feedback form, you may leave the session and please join at 2 o'clock for the session 2.
Sir, SMT 1026.
SMT 1026. Sir, sir, please fill the feedback link, sir. Sir, Patil, sir. What? Message and Dear participants, we will close this session at 12:15. Kindly note. Dear participants, no need of submitting your participant ID in chat box. Please fill the feedback form. Dear participants, no need of submitting your participant ID in chat box. Please fill the feedback form. It's enough. If you have filled the feedback form, you may leave the session, and I request you all to kindly join at 2 p.m. for session 2. We will post a message in WhatsApp group when the link is active for session 2.
हा बोल पुरे आपण नाही लावलं.
Dear participants, I once again posted the feedback link in the chat box. If you fill the feedback form, you may leave the session. We will consider the attendance by using the participant ID, which is posted in the feedback form.
अरे आराम झालं जेवण झालं बस ना चालू जेवण झालं मी याच्यासाठी आलो.
Dear participants, the presentation of first session is posted in the WhatsApp group. You may download from WhatsApp group. Dear participants, same link of WebEx will be used for all the sessions. Kindly note, same link will be used for all the sessions. Babu sir, is that okay, sir? Right, sir. Thank you, sir. ఏం కావాలి? ఏది? ఆఫ్టర్నూన్ 1:45 స్టార్ట్స్. అవును.